The following tutorial will cover the new features added to Policy Manager for the NetSite 5.0 release. Version 5.0 of NetSite brings several notable enhancements to Policy Manager. We'll dig into these further in the coming slides, but in summary, the changes fall into three main categories. Several new features have been added, providing additional security, visibility, and control to the product. These include anti-spoofing, auto-tracking, and quarantine authentication, end-user session hostname resolution support, and a new rule type for classifying traffic. Secondly, building on previous releases, new performance improvements have been built into the switches and leveraged in Policy Manager to shorten verify times. Additionally, the startup verify logic now occurs in the background. Finally, there is now enhanced integration between Policy Manager and both Wireless Manager and the Application ID engine. Policy Manager updates building on this include allowing Wireless Manager to retrieve more detailed information about the configuration and domains, support for the new features found in version 8.31 of our wireless controller firmware, and the ability for the traffic mirror action to send only the first few packets of each flow rather than mirroring all data. The biggest new feature added to 5.0 is support for anti-spoofing intelligence that has been built into the firmware on the SNK devices. Attacks on an IP network can easily be performed using readily available tools found on the internet today. Malicious users can spoof DHCP server response packets, allowing them to give false information to a user for such fields as the default gateway or domain name resolution servers. Man-in-the-middle attacks can take advantage of ARP, allowing a hacker to redirect user traffic through his own device to and from the default gateway, such that the hacker is able to spy on the private information being sent from the user without either the user or gateway knowing. A malicious user can spoof an innocent user's IP address, allowing the malicious user to bypass other possible security features of a network that are based on a user's subnet. Unauthorized servers on a network are able to misconfigure clients so that their traffic goes through the wrong gateway, allowing an attacker access to that traffic, or so that the client has no access to network resources. Unauthorized clients can drain network resources by generating DHCP requests exhausting all of the IP addresses in a server's address pool, blocking other clients from accessing the network. A malicious user or client can send packets from the same source MAC address, requesting IPs for different users by changing the client hardware address field in the DHCP packet. In using this attack, a single client can also remove other clients from the lease database using release or decline packets, effectively removing the user from network access or freeing his address to be used by the attacker. A user who has successfully connected to a network and received a valid IP address has other means of disrupting the network as well. Using gratuitous ARP replies, an attacker can manipulate other devices' ARP tables such that the attacker appears to be another user to a gateway, or the gateway to the other user on the network. This type of attack, the man-in-the-middle attack, allows a malicious user to sniff all the traffic coming from a user without that client ever knowing his traffic is being rerouted to the attacker, using IP forwarding on the attacker's device. The user's private data can then be intercepted by the attacker, giving the attacker access to the user's passwords, account numbers, emails, etc. as they traverse the network. Anterasys solution provides a flexible and secure approach to IP spoofing detection and prevention. To mitigate the effects of these types of attacks, a source MAC to source IP address binding table needs to be created. The three basic tools that will be used to detect source IP to source MAC address associations and take actions on violations are DHCP snooping, dynamic ARP inspection, and IP source guard. Both dynamic ARP inspection and IP source guard can be configured to run in inspection-only mode, limiting the association of IP addresses to MAC addresses to DHCP snooping, or they can create IP to MAC address bindings as well. Bindings created as a result of DHCP exchanges with trusted servers via DHCP snooping take precedence over bindings created through ARP inspection or source guard. Using these three tools allows bindings to be created for users in a network where DHCP is either not in use, or where a DHCP exchange has not occurred since the anti-spoofing feature has been enabled. The actions that may be taken against a violating user include logging a message, sending a notification, or putting the user in quarantine as defined by a policy profile. DHCP snooping provides the foundation for IP spoofing detection and prevention. DHCP ACK packets received on a trusted port from a DHCP server create a MAC to IP binding for the user, along with the lease time and expiration. DHCP ACK packets received on any port that are configured as untrusted are dropped. DHCP release and decline messages sent by a client to free its IP address for another user are dropped as well if they are for a MAC address in the database that is on another port. On edge devices, an optional configuration is to verify the source MAC address of the client with the client hardware address found in the DHCP payload. Dynamic ARP inspection utilizes the MAC to IP binding database to ensure that ARP packets have the proper MAC to IP binding. When ARP packets enter the switch, the source address MAC and IP address is compared to the entry in the table, and if the packet data conflicts with the binding in the table, the IP change is counted and logged, and any configured actions are taken against the user. Dynamic ARP inspection is also used to populate the MAC to IP binding table when configured. Successfully limiting ARPs to the bound addresses in the table prevents a malicious user from inserting himself in between the end user and a gateway and poisoning network devices' ARP caches, or succeeding in man-in-the-middle attacks. IP source guard is another means to restrict IP traffic and take configured actions against violating users. IP traffic on a port is inspected to ensure that a user's MAC and IP address is found in the binding table created by DHCP snooping. A user's IP address changes are counted and action is taken as configured. Like dynamic ARP inspection, the anti-spoofing feature can be configured so that IP source guard is also able to add entries to the MAC to IP binding database dynamically based upon IP traffic traversing the switch. This is particularly beneficial in an environment not limited to edge devices or one in which DHCP is not the sole proprietor of a network addresses. Beyond increasing the security of the network, the station bindings created by this feature can also be leveraged to enhance existing data throughout Policy Manager or NetSite where only an IP address or MAC address is available. We'll see one instance in the 5.0 release that already takes advantage of that. The latest SNK firmware has enhanced the authentication agents to include two new types of authentication. The first is auto tracking. This feature allows a user session to be created for all traffic traversing a switch, even when that traffic is not authenticated by a traditional means such as X, PWA, or MAC. This allows even open networks to report information about who is on the network and where. Secondly, a new quarantine authentication agent has been created. This is the highest precedence authentication type, so when an auth session is created of type quarantine, the network access provided by the other auth types will be removed and replaced by a quarantine role. This is specified by the administrator by means of a new rule action in Policy Manager. This action, labeled quarantine role, can map any role as a quarantine role when the rule is hit. Note, it is left to the administrator to ensure that the specified quarantine role restricts traffic in the manner intended. To help keep track of this, any role specified as a quarantine role will have its icon changed to red, and when selected in the tree, will have a label at the top of the general panel warning of this fact. Next to that label is a button showing the locations that the role is used in this manner. Note that in addition to the quarantine role rule action, anti-spoofing station binding violations can also be set up to assign a quarantine role to offenders. Another new feature in 5.0 in the port usage tables is the addition of a hostname column. When anti-spoofing is enabled on a device, as well as hostname resolution, a setting found in the options, user session information is enhanced to show the MAC, IP, and hostname of a user, even when the session data itself may only contain the MAC address. This provides added visibility into who is on the network. Note that by default, anti-spoofing and hostname resolution are both disabled, so those features need to be configured to see the benefits in the port usage tabs. Version 5.0 adds support for a new rule type for classifying traffic in the SNK firmware. Called application, this rule type will detect network traffic of a particular application protocol, allowing policy management to be applied to that traffic. Bonjour traffic used by Apple devices is the leading reason for this enhancement, although support for additional applications is expected at a later date. At this time, the rule type is not yet supported in the wireless controller firmware, but it is coming soon. The Bonjour protocol is noisy and can use up valuable network resources. Using this rule type, Apple device service advertisement and registration can be blocked entirely, or restricted so that only sanctioned Apple services can advertise themselves, or limited to a particular containment VLAN. The policy MIB, the communication interface between device firmware and policy manager, has been updated for 5.0. Up until today, the current design grouped together user session information with the static policy configuration defined in Policy Manager. This would force Policy Manager to read extra data when doing an enforce or verify. With current devices supporting potentially thousands of users, this would cause Policy Manager to unnecessarily have to walk thousands of entries. The updated MIB removes this performance hit. On top of that, an attribute indicating when the table was last changed exists, but generally could not be exploited as sessions coming and going would update the value. With the static policy configuration now segregated into a dedicated table, we can also legitimately leverage the last changed attribute. This will result in most verify calls that used to require thousands of rows to be read to be replaced by a single attribute read. This should provide a noticeable speed improvement on SNK devices running the latest firmware. Secondly, the main frustration point for verify taking up sizable chunks of time is the fact that when a domain is opened, Policy Manager will run verify to determine that the devices are in sync with the current configuration. While this can be disabled in the options, most customers seem to want to keep this enabled. However, many times when Policy Manager is opened, you want to do something that does not necessitate knowing if the domain is in sync. For instance, you might be changing the policy config, meaning you are going to enforce anyway. Or you might want to configure something on the devices related to authentication, for example. In 5.0, the startup verify now occurs in the background and no longer blocks the user until it completes. The status bar at the bottom of the client will show the status and results of verify. If the domain is modified or a new domain opened, the current verify will be canceled since it is no longer applicable. Selecting the verify button while background verify is running will bring the current verify to the foreground by showing a progress bar rather than starting over from the beginning. .5.0 builds on NetSite Suite integration in a few areas. On the wireless side, more detail is now provided about the domain's role and rule configuration for external viewing in Wireless Manager. We'll see that in more detail in the following slides. Support for new wireless controller firmware updates have been added as well, including policy egress VLAN support, rule level VLAN containment, VLAN dynamic egress status, and support for EtherType and MAC source dest rule types. On the wired side, the SNK firmware has enhanced the policy traffic mirror feature to allow mirrors to forward only the first few packets of a flow. This is used for integration with the App ID solution Antares is building and avoids network congestion. A domain has only one end value, where the number of packets sent can be between 1 and 31. A mirror can either forward all traffic or use the end value to send just the first several packets. Here are some additional notes on Wireless Manager and Policy Manager integration. To summarize, Policy Manager managed concepts are exposed in Wireless Manager, but are read-only. Any additional concepts are handled by Wireless Manager. For instance, information about a topology beyond the VLAN. Wireless Manager will build on data that is read in and automatically create templates and topologies. Here we see how roles defined in Policy Manager are displayed directly in Wireless Manager in the Roles section of the templates. This tab shows the default actions for the role. The tabs shown here show the rules and egress VLANs assigned to the role, exposed in Wireless Manager. This slide highlights the additional capability in Wireless Manager of initiating and enforce in Policy Manager via a checkbox when using the Deploy VNS Service Task Wizard. Here we see the configuration point in Policy Manager for egress VLANs in a role and the corresponding display in Wireless Manager. Egress VLAN support was added to the wireless controller firmware for the 8.31 release. Note that VLANs added to a role as tagged will be enforced to controllers as untagged, as that's the only type that's supported. Also, controllers do not have forbidden egress VLAN support. This wraps up the new features for 5.0.